In this video, we're going to look at balancing chemical equations that involve polyatomic ions. And the particular chemical reaction that we're going to look at is this one here, which is a reaction between copper 2 nitrate and sodium phosphate. And the products produced, copper 2 phosphate and sodium nitrate. When balancing equations that contain ions, it's often useful to keep track of each of the ions and to be able to identify the ions in both the reactants and the products. So for example, in the copper nitrate, we've got the copper 2 plus ion, Cu2 plus. We've also got nitrate ions, and there are two of them. We can see that the nitrate is written in brackets and we've got the subscript 2. So copper 2 nitrate consists of a copper 2 ion and 2 nitrate ions. For sodium phosphate, we can see we've got 3 sodium ions and 1 phosphate ion. For copper 2 phosphate, we've got the 3 copper 2 ions and we've got the 2 phosphate ions. And for sodium nitrate, we have a single sodium ion and a single nitrate ion there. We can see that the number of ions on each side of the equation and the number of atoms on each side of the equation are not the same at the moment, and this equation as it stands is unbalanced. Our hints for balancing chemical equations apply equally well with balancing equations for polyatomic ions, but we're going to add one more piece of advice. We're going to keep the polyatomic ions intact and we're going to balance them as a whole rather than trying to balance the individual atoms. So for example, you can see we've got 2 nitrate ions over here. The idea would be to keep the whole nitrate ion intact and not try and balance the 2 nitrogen atoms and the 6 oxygen atoms individually, because we've got our 2 nitrate ions here on the left hand side, but over on the right hand side we can see we've got 1 nitrate ion. So it would be just a matter of balancing up the whole nitrate ion numbers. Similarly, we've got a whole phosphate ion here and we've got 2 phosphate ions over here on the right hand side. So I wouldn't be trying to balance the 2 phosphorus atoms and the 8 oxygen atoms. I would just keep the phosphate ion unit intact as a whole and just try and balance the ions here. Of course, we've got 3 sodium ions here on the left hand side, and we've got just the 1 on the right hand side. We've also got 1 copper atom on the left hand side here, or a copper 2 plus ion, and we've got 3 on the right hand side over here. So we might just start with actually balancing up these coppers. We've got 1 on the left hand side over here, so I need to get 3. So the way I do that is to put a big 3 out the front of the copper 2 nitrate formula, and that gives me my 3 times the 1 copper atoms on the left hand side, which matches my 1 times the 3 copper atoms on the right hand side. What it's also done though, putting the 3 out the front of the copper 2 nitrate, it's given me a total of 3 times 2, which is 6 nitrate ions. Originally there was 2 nitrate ions, and then I put the big 3 out the front, and so now that gives me 6 nitrate ions on the left hand side. At the moment I've only got 1 nitrate ion on the right hand side. So in order to get 6 nitrate ions on the right hand side, I put a big 6 out the front of the sodium nitrate there. 6 times my 1 gives me 6 nitrate ions now on both sides of the equation. What it's also done, however, it's given me 6 sodium atoms on the right hand side, and at the moment I've only got 3 sodium atoms on the left hand side. So if I put a big 2 in front of the sodium phosphate, I get my 2 times 3, which is 6 sodium atoms on the left hand side, to match the 6 sodium atoms I've got on the right hand side. Now it turns out that this equation is already balanced without us having to explicitly look at the phosphate ions, and this happens quite often in balancing chemical equations. You can see that by putting the 2 in front of the sodium phosphate, I've now got 2 phosphate ions, and these balance out the 1 times the 2 phosphate ions that I've got in my copper 2 phosphate formula on the right hand side. So this equation is now balanced. I've got 3 coppers on the left hand side, 3 coppers on the right hand side. I've got 6 nitrate ions as a whole on the left hand side, and I've got 6 nitrate ions as a whole on the right hand side. I've got 6 sodium atoms on the left hand side, and I've got 6 sodium atoms on the right hand side. And finally I've got 2 whole phosphate ions on the left hand side, and I've got 2 whole phosphate ions on the right hand side. So we're able to balance this equation by keeping the polyatomic ions intact, and we balance them as a whole. So that would be the big hint that I would give out for balancing equations containing polyatomic ions.